Okay. Hi, everyone. Thank you for coming to our talk. We're super excited to be here today. As you can see, we're going to be talking about building dynamic configuration into Terraform. So how you can dynamically evaluate Terraform attributes on the fly, and why you might even want to do this. So let's get started.
So what makes us qualified to talk about this? Well, I'm Hosh. I'm a platform engineer at LaunchDarkly. And apparently I'm really bomb at Terraform, which was written by her.
Hi, I'm Isabelle. I'm an engineer on the integrations team at LaunchDarkly, and as a maintainer of our Terraform provider, I just have a lot of opinions about how Terraform provider should work. So, like all startup stories, this story is about growing pains. We're going to examine a real pain point our platform team has encountered as our engineering team has scaled.
Back in the day, we started throwing all our Terraform configuration into a single repo. Over half a decade later, we've got a massive monorepo that contains not only the infrastructure that we manage, but loads of bits that belong to different engineering teams as well. As the gatekeeper of infrastructure, this means that whenever an engineer wants to update their own stuff, their own things, stuff like monitors, microservices, etc., first, they have to take the time of understanding Terraform, learning it, and figure out how to make changes that fit within our workflow. Then we were the ones who had to review the code, and across a whole engineering org, those bits of time added up. The first and most obvious solution would have been to not put everything in a single repo, but so we can manage permissions on a repo-by-repo basis, but too late for that, and migrating Terraform configurations can be a massive pain. And ain't nobody got time to refactor that.
So we thought, what if we could give engineers controlled access points only to the resources and attributes they care about in a clear and digestible format? That way, no one has to take the time to detangle all of our Terraform modules on the rare occasion they just want to update an SLO threshold, and Hosh here stops getting interrupted by single-line PR review requests.
Wait, really? But how?
Luckily, we work at a feature management company,
where the one-size-fits-all solution is a feature flag.
So actually, though, we use feature flags for loads of similar things across our product. Things like rate limiting, database migrations, pricing tiers, anything that might benefit from the ability to dynamically update values without deploying new code.
Also, luckily, we do week-long moonshots twice a year where we're given the freedom to work with people across the company on prototyping big ideas. To solve this particular problem, we posited that we could integrate the same feature flag functionality of dynamic values into our Terraform code. And hence, the new evaluation provider was born.
So a Terraform provider, as you may know or be familiar, is just an SDK or API client wrapper for Go clients. We already have a series of SDKs that we use to evaluate flags in code, including a Go SDK. This let us build out a new provider that wrapped the flag evaluation functionality of our Go SDK, as you can see here.
We decided to create 4 separate data sources to correspond flag value types to Terraform data types, the classic Boolean, string, number, and JSON. Each time you plan or apply, Terraform evaluates the flag value using the underlying SDK, meaning that you can reference the dynamic values from within your Terraform configuration.
So on the screen here, you can see an example of a feature flag data source that you can use to dynamically update a Kubernetes deployment replica count without having to update the code. So on the top, you can see the data source, and then you can see us referencing it below. And so the value there would be set externally. Oh, sorry. Are we? Yep. OK. Our existing Terraform pipeline currently at LaunchDarkly uses Terraform Cloud's GitHub integration to plan Terraform changes when opening a PR and then apply them when merging it. However, with feature flags, you can make simpler Terraform changes more manageable by removing the need to make code changes at all. So that means that engineers who don't normally work in Terraform don't have to spend time refamiliarizing themselves with layers of Terraform modules every time they want to make a change, and platform engineers are saved the headache of PR reviews for insignificant changes.
With this, Terraform can also be set up to allow management to make changes without any code editing. Since the data sources are hard-coded, you can carefully control what attributes external users have access to. And if your feature management platform allows it, what values are permissible.
Finally, engineers can manage things that matter to them without needing input or approval from platform engineers. Although if your feature management platform allows it, you can still use an approvals mechanism directly on the existing platform without raising a pull request.
We're currently dogfeeding this internally for things like SLOs and monitoring thresholds and editing scaling attributes like the previous example we showed. And we're already seeing some of the benefits come to life. Let's look at another example.
OK, so here you can see we created a JSON data source that contains the thresholds for API availability for a given API, in this case for webhooks, for webhooks APIs. Since we have dozens of APIs that are maintained and managed by different teams, and teams are required by upper management to maintain availability SLOs, this makes it easier for engineers across our organization to tweak and manipulate their thresholds for their individual APIs that they maintain. So all you really need to do in Terraform is a one-time setup of a flag evaluation data source like this one, containing the SLO-specific context. So here we just use like the API. Here we're using the webhooks API. And then moving forward, we can easily set rules on the flag UI directly, as you can see on the right, and rerun a Terraform apply, which in this case, we've also conveniently set up to trigger automatically via an API request whenever this flag is updated.
The flag maintainer can also ensure that bad values do not get set by restricting who can create new options on the flag, so that the only options anyone updating the threshold would have are the predefined ones on the flag. So you can see that
down there.
Yeah. We think that this is a proof of concept of a new frontier in infrastructure as code, leveraging feature management tools to dynamically manage attribute permissions or to dynamically manage your infrastructure. If you're interested in building this yourself, you can do so using Terraform Cloud's custom provider registry.
In the meantime, we're hoping to release it as part of our product with full end-to-end integration for Terraform Cloud applies in the coming months. So feel free to hit us up on Twitter or at our booth if you have any questions or want to know more.
Thanks for coming to our TED Talk. We'll be opening the floor to questions. And like she said, we're also at the booth if you have any questions.